Okay guys, a couple of people have been asking me for this video for a while, so I'll go through it. The chain rule, what is it? How do we apply it? And why should we even care? I think is going to be the crux of this video. So the chain rule is a method to finding a derivative of a function. So it's a method to find the differential of a function or to find a function's gradient function. So we apply the chain rule when we have what's called a function that is composed of another function, or composite functions. So the way that we have this is if we have y in terms of x, but we have y as a function of, and I'll change color here, g. So we've got y as a function of another function, which is the function of x. Let me just keep the colors consistent. So, well, what does this mean? Well, what this means is that when we're trying to find y, x gets transferred or manipulated with a particular function, and then after that has been done, it gets manipulated by another function. A sort of an example of this would be if we had y is equal to the square root of 3x squared plus, I don't know, 7x. So what you can see in this function, the inside function, the g of x in this case, is a quadratic or a power of 2. So it gets manipulated by the quadratic function first, and then afterwards it gets manipulated by the outside function, which is f, which is the square root. So you can see that there are two separate functions in this one overall function. Now, what the chain rule tells us is if we want to figure out what dy dx is, we have to, first of all, calculate the derivative of the outside function. So we'll call that f prime. And then we've got to multiply that by the derivative of the inside function, which in this case is g prime. So what we do with after we've calculated the derivative of the outside function in here, we then keep the inside function constant. So we have the derivative of the outside function in terms of the inside function, and then we times that by the derivative of the inside function. Another way of explaining this as well, another way of writing the chain rule, which I'm just throwing this out there just in case it comes along, and you go, well, hang on a second, I didn't learn it that way, or I haven't been told it this way. Well, the way that they sometimes break this composite function down is they will write, let's have y as equal to a function, but instead of saying it's a function of another function, we say this is a function of u. And we also have u is equal to a function of x. So you can see that we've got y in terms of u and then u in terms of x. So we substitute the u in for g of x. And what the chain rule says, and this is like the classic Leibniz method for writing the chain rule, is if we want to find dy over dx, or the derivative of y in terms of x, we first of all find the derivative of y in terms of u, so dy du, and then we multiply it by the derivative of u in terms of x. And you can see what effect that has on this fraction multiplication is the du's end up cancelling. And we have dy over dx. Okay, so enough talk with just pure mathematical jargon. Let's actually use the chain rule to do a few differentials, a few examples. Okay, so the first example I'm going to do is I'm going to do the differential of this one. So we've got y is equal to the square root of 3x squared plus 7x. Great. So let's figure out what our outside and inside functions are. So here, let's make u equal to the inside, so we can write that down. U is equal to 3x squared plus 7x. And y is equal to the square root of u. So you can see I've got y in terms of u and u in terms of x. So the way we're going to solve this is we're going to rewrite this as u to the power of 1/2. And then we're going to apply the chain rule. So we have the chain, we'll write the chain rule again so you can see exactly what I'm doing. Dy dx is equal to dy du times du dx. So dy du, so the derivative of this is going to be equal to 1/2 u to the negative 1/2. So that's the derivative of that. And then we have to multiply it by the derivative of u with respect to x, so the derivative of this one. So the derivative of u with respect to x is equal to 2 times 3 is 6, x plus 7. Let's put that in brackets. Cool. So we can rewrite this as 6x plus 7 all divided by 2u to the power of 1/2. Because it's negative, I can have to put it underneath the fraction. And then you'll tell me, but Harold, this derivative here has a u and an x in it. We haven't got y in terms of x yet. No, we don't. But what we do know is we know that u is equal to this. So right at the end, which is where we're at now, we substitute u back into the equation. And we have dy dx is equal to 6x plus 7 divided by 2. Now, because this is to the half, that's the same as saying the square root of 3x squared plus 7x. And then we'll just put the top of the square root down. And that, guys, is the derivative of the first example. Now, I'll give you another example using the chain rule. So let me change colour. Okay, so a bit more tricky one, and we'll go, all right, what is the derivative of y equals the tan of x squared plus 2x? Okay, so we'll set it out like this. Obviously, u is going to be equal to the inside function, which is quadratic, and y in terms of u is just going to be the tan of u. So here I've got y in terms of u and u in terms of x. Now, if I want to find the derivative of y in terms of x, the chain rule tells me that I need to find the derivative of y in terms of u and multiply it by the derivative of u in terms of x. So, the derivative of y in terms of u, the derivative of tan of u, is equal to 1 divided by cos squared of u, and then I have to multiply that by the derivative of u in terms of x, which is, I'll put a bracket, 2x plus 2. Great. So we can then simplify or combine our functions, make it look nicer, and have 2x plus 2 over cos squared of u. And like our other one, we have x and u. We need to have it y in terms of x. So right at the end, we find our derivative y in terms of x is equal to 2x plus 2 divided by cos squared of, and then we re-substitute the original u in. Cool. So that's the chain rule. It's used for when we have composite functions or functions inside of functions. And basically the chain rule states that if we have a composite function, the derivative of the entire function is going to be first the derivative of the outside function in terms of the inside function, or f of u, times the derivative of the inside function in terms of our explanatory variable, which in a lot of cases is x. And that will, multiplying them, will give us the total derivative y in terms of x. So I hope that video was helpful. If you need any help with any other rules or questions in any of your subjects in high school, just give us a yell and I'll be more than happy to have a go at it. Cheers.